Lesson 4.1 Work. As students enter the room, show the slide on screen. After the bell rings, show this slide to remind students that they have 5 minutes to complete the bell ringer. While students are doing the bell ringer, check their attendance and distribute the classwork sheets. At the end of the 5-minute period, discuss this bell ringer with the students. Lesson 4.1 Work. By the end of the period, with at least 80% mastery, students will be able to recognize the difference between scientific work and ordinary definitions of work, solve problems involving work. What is work? The common idea of the definition of work is quite different from the technical definition. We often associate work with physical or mental effort that leads to fatigue. The technical definition of work is more limited. A force that causes a displacement of an object does work on the object. There are three ingredients of work: the force, displacement, and the cause. In order for a force to qualify as having done work on an object, there must be a displacement, and the force must cause the displacement. Consider the following situation. The work done by a constant force is defined as the distance moved multiplied by the component of the force in the direction of the displacement. Mathematically, work can be expressed by the following equation. W equals F times D times cosine of theta, where F is the force in newtons, D is the displacement or distance in meters, and theta is the angle between the force and the displacement in degrees. In order to understand its meaning, let us consider the following two scenarios. Scenario A, when theta equals 0 degree. A force acts rightward upon an object as it is displaced rightward. In such an instance, the force vector and the displacement vector are in the same direction. Thus, the angle between F and D is 0 degree. From W equals FD cosine theta, since theta is 0, this equation becomes FD times cosine of 0, and since cosine of 0 is 1, the resulting formula is W equals F times D. Scenario B, when theta equals 90 degrees. A force acts upward on an object as it is displaced rightward. In such an instance, the force vector and the displacement vector are right angles to each other. Thus, the angle between F and D is 90 degrees. From W equals F times D times cosine of theta, and since theta is 90 degrees, the formula is F times D times cosine of 90. But since the cosine of 90 is 0, therefore, the resulting equation becomes W equals 0, and here no work is done. What are some examples of work? A carabao pulling a plow through the fields. Number 2, a father pushing a grocery cart down the aisle of a grocery store. 3, a weightlifter lifting a barbell above his head. And number 4, a man hitting the golf ball. Look at the following pictures and tell whether work is done or not. Number 1, a teacher applies a force to a ball and becomes exhausted. Is there work or not? Number 2, a waiter carries a tray full of meals above his head by one arm across the room. Work or not? The mouse is using a force to move the cheese a distance. Both the force and motion are in the same direction. Is there work or not? Look at the baseball pitcher. Is there work or not? A baseball pitcher is doing work on the ball as he exerts the force over a displacement. A book falls off a table and pre-falls to the ground. Is there work or no work? Yes, there is work. There is downward force, gravity, which acts on the book to displace it. A rocket accelerates through space. Is there work or not? Yes, the expelled gas is the force which accelerates the rocket through space. To summarize, we have the following formulas to find the work done. Letter A, horizontally. 1 W work equals F times D, or solving for F equals W over D. Or if we solve for D equals W over F. Vertically, such as lifting an object to a height h, work equals F times D, which is weight times height. And since weight equals mg, then this is mg times h, where W is the work done in joules, F of the force in newtons, D is the distance in meters, weight is the gravitational force in newtons, h is the vertical height in meters, m is the mass in kilograms, G is the acceleration due to gravity, which is 9.8 meters per second squared. Example number 1. A 100 Newton horizontal force is applied to move a 15 kilogram object horizontal distance of 5 meters at constant speed. Find the work done. So, using formula number 1, work equals Fd, which is equal to 100 times 5, which is 500 joules. Example number 2. 50 joules of work is needed to move a 20 kilogram box horizontally a distance of 6 meters. Find the force applied. Using formula number 2, force is work over D. So work is 50, then divided by 6 equals 8.3 newtons. Example number 3. A worker lifts a 4 block of a distance of 1.5 meters to the bed of a truck. How much work is done to lift the block? So, this using formula, work equals M times G times H. We have 4 kilograms times 9.8 times 1.5 equals 58 joules. We use positive 9.8 because work is a scalar quantity. If there are no more questions, then let the students complete the classwork until the end of the period.